Good morning, everybody. Welcome to another exciting morning of chemistry, Chem 1211, with your host, me, Dr. White. Oh, I'm going to do last week. Exciting times. Oh, actually, it's sad. Dr. White's sad. Why? It's our last full week together. And I'd just like to thank all of you for being in my class, those who are here live and those who are watching this videotape. Thank you. All right, what's going on this week? First of all, today I'm going to talk about important information about the final exam. The final exam I'll be giving a week from today. I will do just like I've done before, except next week is finals week. And because it's finals week, there are no classes. That's part of COD finals week. So therefore, we will not have Zoom lectures next week, but I still will hold my office hours if you need to see me. Now, here's what's going to happen. Today, I'm going to go through important information for the final exam. Then I'm going to go through the answers for test number 4, so you can know what you did right or not. All of you should have gotten an email, except one person who I got tests, I still got a grade. You should all have uh, gotten an email with the points of each question or part of a question you answered, so you know what you did right and wrong. And when I go through the answers, you can check that. One note of caution, I will be taking the answers out of the videotape. If you need them, come and see me during my office hours. If you can't make it to my office hours this week, email me. Luckily with Zoom, I can set up special office hours. I'll do that as special courtesy to you this last week. I would highly recommend you either pay attention or watch the videos for the reviews. Hold on one second. That you watch the reviews because students say it helps them do good on the final. All right, after that, I'll be finished. Now, one thing I haven't done, and I thought I was going to do it, and I'll still do it, Thursday, after the lectures, I'll stick around for a little while and I'll be taking this out of the videotape, but I will give what I started about 2 years ago, having been a senior manager in the chemical industry for many, many years. It died in Chicago. That's why I'm teaching now. Unfortunately, or fortunately, I like them both. I like them both. Uh, I hired people, and I also got hired at senior levels. So one of the things I know quite well is how to interview. And for you people, that interview could be getting into a school like nursing school or getting a job. And I'll give some tips how to interview this Thursday after class. Stick around if you want to. If not, you don't. And it's I've found that students have been quite successful with these techniques. One student got into nursing school. After the interview, she went downstairs, was walking out the building. This was at UIC Nursing here in Chicago. And as she walked out the building, her cell phone rang. And it was the senior member of the 3 faculty who just interviewed her and asked her, could you come back up? And she wondered, oh my God, what did I do wrong? And they asked her to sit down and they said, you know something, the 3 of us have been talking. You gave the best interview we've ever seen, and we're going to offer you a position right now. And she took it. Another student was interviewing, I taught this in an organic class, was interviewing at a hospital for a full-time position in, I probably pronounced it wrong, phlebotomy, stuff with the blood. And she interviewed with the hiring manager, used the techniques I taught, and then she left. And the guy said, I'll get back to you, and I have others to interview. That was a couple of 3:30 in the afternoon. 6 o'clock that night, she got a phone call from that person saying, yeah, I've been thinking about it. You gave the best interview I've ever had. I want to offer you the position. And guess what? She took it. So I'll do that Thursday. All right, I better get to work. Since Zoom still plays with me, everybody see important information on their screen? Nope, okay, I do. The other thing, I did something with the wiring and can you hear the clicking sound now? If you hear the clicking sound, go like this. You can? Try something. All right, I'm gonna do something in a second. Now can you hear the clicking sound? Something about this one webcam, which is a better webcam, uh, causes that. And I've been trying. Now you hear it again? Ah, ah. It's frustrating. I apologize. All right, let's get to work. All right, first of all, Chem final, 12/11 final will be a week from today on the 15th at 10 a.m. There will be no class next week. I will email out the password for the final PDF at that time. You'll have until Wednesday morning, 10 a.m. to take the final and upload it. Now, because it's finals week and I am busy and I have a schedule to keep, I reserve the right to subtract up to 50 points. Anyone who does not upload it properly as a single PDF, and anybody who doesn't get it to me on time unless you check with me and get my approval to be a little late. We got to be on time, people. And that's why I'm going to stick to this. And I will reserve the right to take up to 50 points. So don't be late. All right. The final exam is 17 pages and 46 problems. There are 8 multiple choice, and some questions have multiple parts. Relax, take a deep breath. I give the same kind of final when if we were face to face in a classroom and students do good. And I'll explain why you should relax in a little while. All right, the final will be comprehensive. It covers everything I covered during the semester. Now, from test 1 material, there'll be 53 points on the final. From test 2, there'll be 60. Test 3, 49. Test 4, 42. And new material, radiation, nuclear energy, 6 points. If you add this up, it adds up to 210 points. Also, like the test, I'll have at the end important information. If you go to the lecture folder of Blackboard for this class, you will see important information for the final exam. That's stuff you do not have to memorize. Now, I'd highly recommend that you download the final exam, the periodic table, and the PDF file for instructions on Monday. I should have the final up ready for you to download sometime Monday. If you have any questions while you're taking the final on Tuesday, and I should have also put there Wednesday morning, I'll be checking my email. There'll be no Zoom meeting lectures next week because it's final week. Now, I'll be posting your final exam score along with all your final grade and all your points by Sunday of the next, not this Sunday, but the Sunday after the final by 1 p.m. or earlier. I'm shooting more for Friday or Saturday. I have another class I'm giving a final. At that time, I'll post an announcement and you'll get an email that your scores and final course grade are in Blackboard. Now, a couple things. One, the final is 210 points, and there are 10, yes, 10 bonus points, just like there were 5 bonus points on all except the first test. And this is to help you out. The other thing is, most students, the average score, and I've been teaching 1211 a number of times here at COD, so I can say this with a surety because I know how to write a final, and that is the average score for a class typically is about 170 to 180 points out of 210. You say, oh, that many missed? No, not really. If you divide that by 2, that's same as getting between 85 and 90 on my hourly exam. And if you think about it, if you have a class that gets 90, 87% the average on a final, that's doing pretty good. And most students do good. Now, what's the best way to study for the final? Use your hourly exams as practice problems. You've been allowed to keep them. And by the way, if you were in face-to-face in a classroom with me, I always let students keep their exams, which is why every semester I have to write new exams. But use those as practice problems, just like you did practice problems for my hourly exams. If you can do the practice problems from the hourly exam problems as practice problems correctly, you'll be set up for the final. Why use the same problems on the final? No. Why use similar ones? Of course. Look at your hourly exam and look at the practice problems. That's why I call them practice problems. Any questions on the final exam? All right, quick commercial from Dr. White. If you like what I did this semester, go to ratemyprofessor.com and put something nice down there. If you didn't like what I did this semester, go to Rate My Professor and warn students not to take me. Now, if you really, really like what I did this semester, send an email to the Board of Trustees, copy the president, and I'll send out email with those links if you're interested. And with that, any questions on the final?
Dr. White is going the final is gonna be like we have to do the practice problems from 1 to 4 to just to do better on the final test, or it's gonna be like separate final exam practice problems.
Nope. I'm not
Okay.
use your hourly exams as the final exam practice problems.
Okay.
Or you can go back and do all the chapters again. Oh, one thing I should say about the final. The first part of the final, first couple pages will be from test 1 material. The second part will be test 2. Third part will be test 3, test 4, and then at the end, nuclear radiation reactions and nuclear energy. Instead of playing like a deck of cards, shuffling everything, I figured that's a little tiny little gift for you. And it works well for students. Uh, and take, normally if we were in a classroom, you'd have 2 hours for that final. And most students are done within about an hour and 15, an hour, 20 minutes. Again, I write my final like I write my exams. If you studied, you shouldn't have any problem doing that. If you've practiced, if you haven't, well, you could have all day and the rest of the week and you're still going to have problems. All right. All right, let's go on to test number 4. Go through the answers. Now, there are 2 versions, and a lot of it was similar, but there are a few that were different. And you'll see I just made minor changes to see if anybody was cheating. And I'll do something like that on the final also. Please don't cheat. All right, hold on one second. All right. Now, one of the questions I would have if I were in your shoes, probably wouldn't fit in them, but if I were in your shoes, I would ask, see, even the last week of class, I can bang out awful humor at no extra price to you. But seriously, I would ask, well, how many points do I have to get on the final to get a grade I want? And that's an important question. Well, first of all, one answer is you should assume you need every point you can get on the final and work as hard as you can to get that and study as hard. But to help you out, to ease your fear, in case you're wondering where you are, I'm going to go through something. Now, this assumes you've handed in all your labs, at least 12 of the 13, because otherwise, if you're missing a lot of labs, the bet is all off because you're missing a lot of points. But most of you have all your labs in. If you notice, Dr. White was a really hard grader, not. But watch closely. And I've done this before, and at the end, I'm going to give you an important caveat. I've got enough time. All right. Everybody see X on their screen? Thank you. So clicking still doing clicking? All right. I'm going to have to I don't know, make some offerings to the computer gods. But anyways, assume X is the sum help if I could spell. X is the sum of your 3 highest tests plus the extra credit project. Those scores are now in Blackboard. So how many points do you need to get an A? Well, take 450 and subtract X. And that number, let's call it Y, will tell you how many points you need. And let's call it Y sub A. For B, 400 minus X gives you a number Y sub B. That's how many points to get a B. For a C, Y sub C. And for a D, this. Let's do an example. Let's say you did real good, and on 3 of the tests, you got 100. So X equals 300, and you didn't do an extra credit. So to get an A, you need on a final 150. Remember, that's under 210 points. If you divide this number by 2, that equals 75, and that's the same as getting a 75 on my oral exam. So you're pretty good shape. So hopefully this helps you understand, I won't cut this out of the video, that this gives you a good indication of what you need on the final. Now, everybody write that down or copy. You can go back and look at the video. I won't cut this out. All right. Now, an important warning. I've had students do that, and they say, oh, I don't need a lot of points in the final, and they don't study that hard, or they barely study. And guess what? They bomb the final. Do people still use that term when you do awful on a final? I mean, they bomb it. And what happens is where they could have gotten a certain grade, they get a lower one or 2 grades lower. I've had more than once, and it's not pleasant for me to see it. I'm sure it's not for the students. They're doing A work. They didn't study for the final. I don't have to study for the final. And they go ahead and get a low score, like 100 or less. And instead of getting an A, they wind up with a B or C. So this gives you a little peace of mind, but I would still assume you need every point to get the grade you want. And that way you won't be disappointed. Like I said, if students study, which you should, please use your tests as practice problems. The average I would expect to be between 170 and 180, which is approximately 85 to 90, which is similar to what I've seen on the hourly exams, give or take a few points. Any questions on that? Well, I'm going to tell you what, let's take a break. I'll give you a whole extra minute. We're on time to go. I'll be doing stuff today to review when we come back, and I'm going to go stretch. So come back at, actually, we're right on time. Come back in 5 minutes at 10:55, and I'll see you then. Time to start again. All right, what I'm going to be doing is going through the reviews from tests 1, 2, 3, and 4. And some of the parts of the review, I'll do some more practice problems with you, and this will help. Anything you see on the screen uh, that's a review. Don't forget, those reviews are in the lecture folder of Blackboard. Also, you can watch this video. Now, one of the things, because I got swamped yesterday with certain things, other things are happening in my life, hopefully good things, uh, that uh, I'm running a little behind on yesterday's class video. So today's video, normally I have it in by the evening. I'll probably have it up in YouTube by tomorrow morning. This is, life happens. Oh, by the way, if anybody of you know anybody, you're a congressman, let me know. Well, I'm going to check with mine because I have ideas I want to put forward to them, how to help people learn better online, especially high school and grade school. Now, with the pandemic running wild, be careful out there. We're not going to be face to face in January or February, who knows when. Anyways, let's go back to something more nicer. All right, everybody see test 1 review on your screen? Thank you. All right, let's go through this. First of all, I started out the semester teaching about the branches of chemistry. You should know one of the 4 at least. And the best one is organic, but that's because I'm an organic chemist. There's also inorganic, physical, and analytical. Next, I talked to you about learning the chemical symbols, like H is hydrogen, O is oxygen, and you should still know those. And you've learned them during the semester, at least I hope you have. Next, I talked in chapter 2 about the metric system, and there are some key prefixes you should know. Kilo, like in kilogram, kilogram, or kilometer, is 10 to the third. Milli, like in milliliter, is 10 to the minus third. Centi, like in centigram or centimeter, is 10 to the minus 2. Even though I have nano down here, you don't have to know that. At this point, I taught you about scientific notation. Remember, that's the number that has one x or y times 10 to the x. Remember, this part of it can never be less than 1 or 10 or greater. And this number can be whole numbers, negative or positive. And I would ask you, write the following in scientific notation. See, Dr. White's going to share it this morning. So it's your turn, write it in scientific notation. All right, time's up. If there was a decimal here, you move it to the right of the first non-zero number. 1, 2, 3. All zeros at the end with no decimal are dropped. I moved it 3 times, so that would be 10 to the third. Now, when the number is greater than 1, or if it's greater than 10, x is positive. If it's less than 1, x is negative. And why don't you do the next one? Write that number in scientific notation. In case you can't see it, there's a decimal. All right, let's do this. You move the decimal point to the right of the first non-zero number, 1, 2, 3, 4, and this would be 4.637 times 10. Notice this is less than 1, so it's going to be negative. How many times? 1, 2, 3, 4, minus 4. And you should know how to do that. Go back and look at the test problems or the practice problems to learn how to do that again, in case you forgot. Next, I taught you about significant figures and how to round off. And there, remember, all non-zero numbers are significant. All zeros at the end without a decimal point are not significant. All zeros at the beginning of a number, even with a decimal point, are not significant. All zeros that are confined in between non-zero numbers are significant, and all zeros at the end of a number with a decimal point are significant. And as you learned how to round off, oops, wrong thing, right thing. All right, let's call it A, B, and C. How many significant figures are in A, B, and C? Have some fun. And when you're done, give me a thumbs up or a smile and give me the high sign. All right, I think everybody's done. Let's take a look at the A. All non-zero numbers are significant. 1, 2, 3. Oh, look, we have a 0. It's after a decimal point, so that's significant. So the answer here is 4 significant figures. Now, ooh, zeros, but they're lead zeros, even with a decimal point. Therefore, they're not significant. Non-zero numbers are. This would be 2. And then Dr. White threw in everything but the kitchen sink on the next one. Non-zero numbers are significant. 1, 2, 3, 4. Zeros that are confined are significant. 5. Zeros at the end of a number with a decimal point are significant. So that's 1, 2, 3, 4, 5, 6. And that's how you do that. Now, for rounding off, round this number off to, let's do 2 significant figures. And let me give you another one also. And round this one off to 4 significant figures. And then I'll do it. See how nice I am today? I'm sharing. Dr. White doesn't want to hog all the fun. If I say fun enough times a semester, you might believe me. All right, let's take a look at this. How do you round this one off to 2 significant figures? Remember, when you're multiplying and dividing, your answer should have the same number of significant figures as the number you're multiplying and dividing that has the fewest significant figures. So what if you have to round it off, this number on your calculator, to 2 significant figures? You keep this number. Keep the first non-zero number, the second one. And this is the number you round off. Is that 4 or higher, 4 or less, 5 or higher? It's 5 or higher. You drop all this and increase this by 1, and this becomes 4.7. Let's look at this one. How do you round this off to 4 significant figures? Keep all non-zero or significant figures, 1, 2, 3, 4. This is number 5, I'll use that to round off. Is that 4 or less or 5 or higher? And 4 or less, drop that, and that would be your answer. And that's how you round off. And that was something new I had to teach you, which is quite important. Once again, I threw in, at this point, know your chemical symbols. Have you noticed how I repeat myself a lot? And repetition, I hope we found out, is good for your grade and also good to help you learn. Now, next chapter, we start getting some chemistry. And first of all, I talked about matter. What is matter? Something that has mass and occupies space. And then you go back and look at the videos I have on there, and I can't do it on a PDF, but hint, important, know this. Oh, I can do this. Know this, the 3 states of matter. And they are solid, liquid, gas. If we were together in a classroom, I'd have you say the first one. Everybody would say solid. Say the second one, liquid. Say the third one, gas. And you should know that a solid has definite shape, definite volume. And you can go back and check the notes. A liquid has definite volume, but indefinite shape. And a gas has indefinite volume and indefinite shape. I'll say it again. Solid, definite shape, definite volume. Liquid, indefinite shape, but definite volume. And finally, gas, indefinite shape, indefinite volume. Next, I talked about the chemical properties and physical properties of matter and no examples for each. A physical change is when you change from one state of matter to another, something like an ice cube melting, you boil water. A chemical physical property is something you measure, or observe. I got ahead of myself. Like, what color top am I wearing? Red, for those who have color TV. I just did a generation gap thing on you. Who doesn't have a color monitor? But anyways, I don't even think they make black and white monitors. And a chemical property is something that describes something pertaining to the chemical, such as does it rust? Is it combustible? Things like that, how it undergoes chemical changes, the ability to undergo chemical changes. Now, physical chemical change, a physical change would be water boiling, ice cube melting. A chemical change would be, and I think I mentioned it earlier, most organic chemists when they were young were pyromaniacs, like to burn things. Chemical change is when you have a candle burning. The wax is burning and undergoing a chemical change. Another example is when you digest food in your stomach and intestine. It's undergoing a chemical change. Next, I talked about how the different temperature scales, Fahrenheit, Celsius, and Kelvin, and I taught you how to convert from one to the other. This information will be an important information, a test of the final exam, but you got to know how to use it. Remember, in the first one, 1.8 and 32 are exact numbers. Exact numbers are numbers that don't play a role in figuring significant figures. So whatever degrees C are given is how many significant figures your answer should have. Next, degree C is degrees F minus 32 divided by 1.8. 32 and 1.8 are significant figures. And at this point, I warned you, a common mistake students make is they take degrees F divided by 1.8, take 32 divided by 1.8, and then do the subtraction. No, you got to do the subtraction first. And finally, for Kelvin, come on, go away. There. Kelvin is degree C plus 273. 273 is also an exact number. And remember, addition, you get the same number of significant figures past the decimal as the number you're adding that has the fewest. Well, in this case, 273 doesn't play a role in that. Now, we really started getting into chemistry, and Dr. White got happy because I got to talk about the atom. And the atom is the smallest particle of an element that has all the properties of an element. An atom is the smallest particle of an element that has all the properties of an element. Then, hint, know this, I talked about subatomic particles. Those are the particles that make up the atom. And the first one is an electron that has a negative charge. Excuse me, getting all choked up over this. Next one, proton, positive charge. Neutron, no charge. And you should know this. Know this. And if you were in class right now, I'd ask, class, everybody, what's the first subatomic particle? Loud, come on. Electron. What's the second one? Proton. What's the last one? Neutron. Then I would say, remember, electron negative charge, proton positive charge, neutron no charge. Next things you should know, I talked about Thomson's cathode ray experiment to which showed that electron had a negative charge. Again, Thomson's cathode ray tube experiment showed that electron has a negative charge. Next, which was a very great discovery, I talked about Rutherford's gold foil experiments. And what he found was the nucleus of the atom, that's the center of the atom, is very dense. And this is something you should also know. The nucleus contains protons and neutrons. The center nucleus of an atom contains protons and neutrons. Now, we started looking at the periodic table, and the atomic number, the number in the upper right-hand corner of our periodic table, tells you how many protons are in an element. And since all atoms have a net zero charge, the number of protons also tells you the number of electrons. Which if you look on test number 1, I asked a question on that. Atomic number equals the number of protons and the number of electrons. When we looked at the periodic table, there were key groups: the alkali metals, the alkaline earth metals, the halogens, and the noble gases. Let's see if I can get my hands on a periodic table real quick. Everybody, you see the periodic table on your screen? The first column, not including hydrogen, are your alkali metals. And I only asked you to learn lithium, sodium, and potassium. The second column are the alkaline earth metals. The first one are the alkali metals, alkaline earth metals, and magnesium and calcium. And the second to last column, fluorine, chlorine, bromine, iodine, are the halogens. And the last one are the noble gases, helium, neon, argon, krypton. And remember, in our universe, unless I got stolen to another one, krypton is a colorless gas, Kr, that doesn't kill Superman. And you should know alkali metals, alkaline earth metals, then over here, halogens, and finally the noble gases. And on test 1, I did ask you, give an example, chemical symbol and name of a halogen. And I believe also a noble gas. I may have asked another one. Now, while we have this here, the upper right corner, like oxygen, has 8, tells you that there is 8 electrons and 8 protons. Argon, 18, 8 electrons, 18 protons, 18 electrons. I got stuck on oxygen for a second. All right, let's see if all right, talked about a metal, and a metal has property of luster. That means you can shine it up. Thermal conductivity conducts heat. Electrical conductivity conducts electricity. And malleability, you can pound on it, make it thinner. Can't do that with a diamond. Don't try that at all. And that's test one material. Next, we went into test number two. I'll go into test number two material. And the question is, where are the electrons? And the electrons are in the electron cloud surrounding the nucleus, which has the neutrons and protons. And here I taught you that you have electron shells, and shells are where electrons have approximately the same amount of energy and same distance from the nucleus. And the shells had very hard names: shell 1, 2, 3, 4, and 5. And then each shell has subshells, and the subshells are, each subshell is where electrons have the same energy and the same distance from the nucleus. And I taught you shell 1 has one subshell, 2 has 2, 3 has 3, 4 has 4. Now the subshells, and I should point out here, shell 1 has the lowest energy electrons, shell 4 has the highest. And that I don't give you on important information. You got to remember that. I'm going to make you remember little things. And you always, when you're filling electrons, start the lowest first. Now the shells have, subshells have names as letters, S, P, D, and F, and the lowest to highest, where S is the lowest, F is the highest. Now that you don't have to memorize, other than here, S has the lowest, then P, then D, then F. Remember, keep this a secret. Remember, my gift to you is you only have to know up to atomic number 12, I think that's magnesium, how to do electron configuration, which I'll talk about in a second. And remember, shell S, subshell S, you can only put 2 electrons, P6, D10, F14. Because of my gift, you only have to know S and P. And I talked to you about the electron configuration. That's, and I'll never ask what it is. That's a statement how many electrons an atom has in each of its subshells. And hint, use numbers, letters, and superscript numbers. Again, electron configuration, numbers, letters, superscript. if I were to ask you to draw the electron configuration for oxygen atoms, what do you do? Well, first of all, you find a periodic table. And everybody see the periodic table on your screen? You look at oxygen, how many electrons does it have? The atomic number tells you that, and it's 8. So oxygen has 8 electrons. Hang in there. If I were in a classroom, you'd be watching me write this. And now you can still watch me write it. All right, so what do? Remember, a subshell is both a number and a letter. A subshell is a number and a letter. The first shell is 1 and subshell is 1s. How many electrons can I put in there? And the answer is 2. And you show that by a superscript. Well, I got 2, but I got to get 8 total, so I have 6 more. 1 has 1 subshell, which I have filled with 2 electrons. So I now go to the second shell. And what's the first subshell? S, it's always the lowest. Remember, lowest to highest energy for both of these. And now we'll do 2s. How many electrons can I put in there? 2, because it says right up here. You know, everything I read on the whiteboard is true. I try to. And now I fill this up. Notice shell 2 has 2 subshells, 2s and 2p. And how many electrons do I have? 2 plus 2 equals 4. I need 8, so I need 4 more. How many electrons can I put in any p orbital? 6. Well, I'm going to put 4 in, and I'm done. And that's how you do it. Why don't you try nitrogen? And nitrogen has 7 electrons. Now, I'm going to give this to you, but you have to look this up yourself. And I'll leave this table up there. You got 7 electrons to deal with for nitrogen. Boy, time flies when you're having fun with chemistry and Dr. White. Can't believe it's already 11:30. And when you're done, give me a thumbs up. Thank you. For those of you watching on the videotape, pause and start again when you're ready. I never said that before. I'll never say that again, maybe. All right, let's do it. How do we do this? We have 7 electrons. What's the first shell? 1. What's its first subshell? Look up here. Oh, lowest energy is S. How many electrons can we put in one S? And the answer is 2. Well, I'm going to do that. Now, shell 1 only has one subshell, 1s. I filled it. Now I have to go to shell number 2. What's the first subshell in shell number 2? Subshell letter and number? It would be 2s. How many electrons can I put in 2s? And the answer is 2, as you can see right here on the chart, which you will be given in the final. Now, how many subshells does 2 have? And the answer is 2. And the first one is S, and the second one is P. You always fill from lowest to highest. So 2P. How many electrons can I put maximum in 2P? 6. How many do I have to go? Well, 2 plus 2 equals 4. 7 minus 4 equals 3. I have 3 left. I could put 6, but I only have 3, and I'm done. And that's how you do electron configuration. Now, the next thing I talked about was the valence electrons. And you should know, hint, because I asked that on test number 2, what are valence electrons? Those are the outermost electrons of an element. The valence electrons are the outermost electrons of an element. How do you know how many valence electrons an element has? You look at the top of a column of the periodic table. Hopefully everybody sees the periodic table. This is the one you'll download like you used all semester. And if you don't know your Roman numerals, I wrote in red the numeric numbers. And if we look at how many valence electrons does sodium have? And the answer is 1. See the number 1 on top? How many valence electrons does potassium have? Well, K, first column, 1, 2. Also, then, how many valence electrons does carbon have? Well, carbon is over here. Look at the top. It's 4. Now, listen. Valence electrons are not total electrons. The number inside the box, the upper corner, tells you how many all electrons. Valence electrons are only the outermost electrons, so therefore carbon has 4. And I'm going to let you try 2 on your own. How many valence electrons does oxygen have? And how many valence electrons does argon have? All right, which halogen? Did I say iodine? Which one? I forgot.
You say argon.
Argon. If I had one before that, I'll do argon first.
Oxygen and argon.
Okay, thank you. I think it's time for me to almost end class. My brain is shutting down. I hope not. Anyways, oxygen. What do you have on top? The number 6. If you know your Roman numerals, it's 6 there. And that means oxygen has 6 valence electrons. Argon, a noble gas, look on top, it has 8 valence electrons. What am I supposed to be doing? No, I'm not losing my brain yet, thank God. All right. Next thing I talked about is Lewis structures. And Lewis structure is a way of showing very quickly how many valence electrons does an element have. And it only deals with valence electrons. And you put one dot on each side of the chemical symbol before doubling up. And in real life, I'd actually write out sodium, oxygen, and bromine. And sodium has one valence electron, therefore the Lewis structure would be one dot. It could be on any side. Oxygen has 6 valence electrons. And here, one on each side, and now I'll double up. Organic chemists always put the double on top, but you could have written it this way. I'm gonna do something unnatural for Dr. White. Ooh, I'm shaking. I got a big chill up my spine. Oh, that's not right, Doc. Don't do that, but I did it. All right, bromine has 7 valence electrons, and therefore you do the chemical symbol, one on each side, and then start doubling up. I did that way. You could have also done it this way. Two sides, one side has 1 electron, the other 3 has 3. Now I'm going to let you try one. Whoa, get back down. Now why don't you draw the Lewis structure for nitrogen? It has 5 valence electrons. Remember, valence electrons at the top of the column of the periodic table. All right, anybody need more time? Going once, going twice. All right, nitrogen, the Lewis structure. Put down the chemical symbol, then one dot on each side, and then double up. You can do any side. Organic chemists like do the top, but you could have, I'm going to do something totally unnatural. I got to force myself to do this. Oh, that doesn't look right. But anyways, it is. And one side has 2 dots, 3 sides have 1 dot. What's wrong if you do something like this? That's wrong, because you never put more than 2 dots on a side, and you put 1 on each side before you even double up. And if I look at the clock, oh no, this is a good time. We're done. Remember, use your tests as practice problems. Also, for anybody who's missing labs, get them in this week. Dr. White's been real nice this semester. Normally, it's more than a week late. And if you can't put it in Blackboard, email it to me. I'm going to try and work today and tomorrow morning before Thursday, send out emails to everybody who's missing labs, and I'll give you one last chance. Get them in. They're easy. 11 point. Oh, I only have 10 feet. Hold on. They're easy 11.0. Am I creative or am I creative? Anyways, am I good or am I good? Don't forget, they're easy 11 points. I gotta do this again. They're easy 11 points. I'm gonna have to use that again. But anyways, don't forget, get them in, study for the final now. You've got all week. Don't forget Thursday after class, for those who are interested, I'll do how to interview, give you tips how to interview. They work quite well. And with that, oh, don't forget, hand in the lab that's due on Thursday also. With that, I'm going to say, signing off from COD North in my home in Schaumburg, and gang gesund. Be careful out there. It's getting really nasty out there with the virus. Be careful, wear a mask. Really, gang gesund, be healthy, and I'll see you Thursday morning. Bye.